Hello friends, let's begin with the spectroscopy topic. In this topic or in this video, we will discuss the meaning of spectroscopy and electromagnetic spectrum. When we are going to study the different spectroscopic technique which are used for the identification of the structure of the organic compound, then we have to know the basic of spectroscopy. So in this video, we will discuss the basic of spectroscopy. We'll start with the meaning of spectroscopy. Spectroscopy is nothing but the study of interaction of electromagnetic radiation with the matter. We know that it is the old definition. Nowadays, this definition is extended to the interaction of electromagnetic radiation with the matter, including a electron, a proton, ion, as well as other particles. When this matter or particles, when they interacted with the electromagnetic radiation, the certain changes are occurring in the matter, and these changes are nothing but a rotation of the matter occurs or the molecule occurs. Vibration is also possible. Excitation of the electron may observed, or in some cases a breaking of bond also occurs. In addition to this, when the magnetic nuclei is present in the molecule, then that magnetic nuclei may excite it to higher energy levels. These changes, they depends upon the nature of electromagnetic radiation, what is the energy of that electromagnetic radiation, and what is the wavelength of that electromagnetic radiation. Now, we will see how the electromagnetic radiation interact with the matter by using a interactive simulation. These interactive simulations, they are freely available on the website of Colorado University, and you can go through that website and you can have a different type of electromagnetic simulation. So we will see uh, interactive simulation of light and molecules, and from this simulation the idea of spectroscopy you can understand easily. So let's go to the website. On this side, there are different molecules. So here we take nitrogen dioxide as a molecule. Then this is having a nitrogen as a central atom and two oxygen. These are the two oxygens. Then here there are different electromagnetic radiation with increasing energy. So just we go through the light spectrum diagram. So here you can find different electromagnetic radiations having different energy as well as frequency and wavelength. The wavelength is inversely proportional to the frequency as well as energy, whereas frequency and energy, they are directly proportional. It means that when wavelength increases, frequency decreases, energy decreases. Now, let's go to the interaction. Here, first of all, we will take microwave radiation, and when it is passed over this nitrogen dioxide molecule, then you can see here, we will take a slow motion. Then here you can observe when microwave radiation is passed, the molecule is rotated. Then we will take infrared radiation. Here, when infrared radiation is passed over the molecule, then this molecule is going to vibrate. So the vibrations are occurred when IR radiations are passed. If you take a visible radiation, then this molecule absorbs the energy and it gets excited. So the excitation of the electron occurs, and in other radiations, it may involve the breaking of the bonds. It may involve the excitation of the magnetic nuclei. So in presence of different electromagnetic radiations, different changes are occurred in the molecule. So from this simulation, the idea is clear. That is, molecule or matter is interacted with the electromagnetic radiation and certain changes are occurring in the matter or a molecule. Now we uh, go back and we will discuss the electromagnetic spectrum. The simple electromagnetic spectrum is looking like this. On this side, these are the ionizing radiations, where on the left side, these are the non-ionizing radiations. The ionizing radiations are X-rays and gamma rays. They are having a smaller wavelength and higher frequency. Now, the wavelengths are reciprocal or inversely proportional to the frequency, as well as inversely proportional to the energy. That's why these ionizing radiations, they are having higher energy and higher frequency. Therefore, they causes the ionization. Now, on this side, the non-ionizing radiations, they are having a longer wavelength. These are the radiations which are having a longer wavelength, and here you can see a wavelength is shorter, but the frequency, if you compare with the ionizing radiation, then these non-ionizing radiations, they are having a frequency that is a shorter frequency or smaller frequency, and energy is less. Whereas on this side, energy is more as compared to the non-ionizing radiations. Now, here you can see a gamma rays, X-rays, then ultraviolet rays. Here it is the visible region which is having a different color, that is violet to red, that is Vibgyor we called. Then this is the infrared, then microwave, and these are the radio waves. So depending upon the wavelength, their frequency as well as energy, they are having different uses. So these gamma rays, they are used in the treatment of cancer, whereas these X-rays, they are used in the study of fracture, that is broken bones. Then these ultraviolet radiations, they are basically used in the ultraviolet spectroscopy, where we can see the electronic transition from lower state to higher state. Then these visible radiations, they are also used in this visible spectroscopy involving electronic transitions. Then infrared radiations are there. They are used in the IR spectroscopy, where when this infrared radiation are passing or passed over a molecule or a matter, then a vibration of that matter or a molecule occurs. Then these microwave radiations, they are used in the rotational spectroscopy, where molecule undergo rotation when it is facing a microwave radiation. And these radio waves, they are having less energy, therefore they causes the excitation of the magnetic nuclei. And these radio waves, they are generally used in the NMR spectroscopy, which gives the clear idea about the uh, position of the proton, position of the carbon, depending upon the delta values. So this electromagnetic spectrum is having different electromagnetic radiations. They are used for the different purposes, and they are having characteristics, wavelength, as well as frequency, as well as energy. But one thing is clear: wavelength is inversely proportional to the frequency as well as energy, whereas frequency and energy, they are directly proportional to the each other. Now you can see here, these are the sources from which we get a different electromagnetic radiations. So we have studied interaction of the electromagnetic radiation with the matter, that is the concept of spectroscopy and the electromagnetic spectrum in this video. Now in the next video we will study the different characteristics or different terms used in the spectroscopy and how they are related with each other.